In this video, we're going to look at the learning target. I can graph quadratics in Vertex form to solve real-world problems. So number one says a hovercraft takes off from a platform. Its height in meters, x seconds after takeoff, is modeled by the function h of x equals -1/2 x minus 3 squared plus 6. So kind of the scenario here is imagine there's a platform of some sort, and we have a hovercraft that's sitting on top of it, and it launches off and comes down like a parabola. Okay, so we need to sketch the graph of this function, and then we're going to use that graph to figure out what the maximum height of the hovercraft is, when does the hovercraft reach its maximum height, and how tall the platform was that it launched from. So to do this, we just need to graph this. So to do it, we know that -3 shifts us right 3, and the +6 moves us up 6. So on my graph, I'm going to go right 3, up 6, and that's going to be where the vertex of my parabola falls. Then from the vertex point, I just use my stretch. So my vertical stretch is actually a compression here, and you'll notice it's negative, so my graph's going to be flipped upside down, right? So from this point, I'm going to go over 1, down a half, over 1, down a half. And then remember, when we go over 2, normally we would go up 4, but we're going to be flipped, and we're going to be compressed in half. So instead of moving 4, we now move 2. So we're going to be moved -2, over 2, down 2. Okay, so our heights have been compressed, and we've been flipped over. Then I can just draw the parabola through those 5 points, and I'm going to use this graph then to answer these questions. So it says, what is the maximum height of the hovercraft? Well, the maximum height is at a height of 6, right? 1, 2, 3, 4, 5, 6. So I would say 6 meters. Then it says, when does the hovercraft reach its maximum height? Well, if my height is the y-axis, right? This is my height. The time in seconds is my x-axis. So the maximum height hits at 1, 2, 3, right? The axis of symmetry here is at 3. So it's at 3 seconds when I reach the maximum height. And then it says, how tall is the platform? So we're trying to figure out where do we cross the y-axis at? Well, if you remember, our y-intercept here is when x is 0, right? We're at time 0. So what we can do is we can plug 0 into the formula, into the function, and then just evaluate it to figure out what height we were at. So the height at 0 seconds is equal to -1/2 0 minus 3 squared plus 6. Well, if we follow our order of operations, we're going to get -1/2. We do the parentheses first, so 0 minus 3 is -3 squared plus 6. And then we do exponents, so -3 squared, well, that's really -3 times -3, which gives us 9. So we get -1/2 times 9 plus 6. Well, then that's going to be equal to half of 9 is 4.5, and it's negative, so we're going to get -4.5 plus 6, and then -4.5 plus 6 gives us 1.5 meters. Okay, so what that's telling us is our height that we launched from was 1.5 meters, and so this platform was off the ground by 1.5 meters there. Okay, so let's go ahead and look at a second example here. So number 2 says, Amir stands on a deck and throws a ball to his dog who is at ground level. The ball's height in meters above the ground, x seconds after Amir threw it, is modeled by this function, h of x equals negative x minus 2 squared plus 8. We need to graph the function and then answer questions again. So to sketch a graph, remember this is going to take me right 2 and up 8. Right 2, up 8, that's my first point, that's the vertex. And then if -1 is the stretch, remember that's just going to reflect me. So when I go over 1, I'm going to go down 1. And when I go over 2, I'm now going to go down 4. Okay, it's going to take that second stretch that we talked about, and it's just going to make it negative. So then I can draw my parabola going through those 5 points. And now I'm ready to use my graph to answer some questions. So it says, what is the maximum height of the ball? Well, it goes up 1, 2, 3, 4, 5, 6, 7, 8, right? It reaches a height of 8. So I would say 8 meters is the maximum height. Then it says, when does it reach the maximum height? Once again, if y is the height, x is the time in seconds. So at the vertex, we are at 2 seconds, right? And that's when it reaches maximum height. So we would say 2 seconds is when it reached the maximum height. And then lastly, it says, what height is the ball thrown from? So what height was it released from? And this time, we can either use the point on our graph, because when we went over to down 4, it gives us this height. So if we do that, we can see that it goes up 1, 2, 3, 4. So we can say 4 meters, which is the answer. But if we didn't have this point, just like we did in the first example, we know that this height occurs when x is 0, and we can simply just plug 0 into our function. So if I do it that way, if I go the long way here, you would get h of 0 equals negative 0 minus 2 squared plus 8. And then once again, we just follow our order of operations. So we're going to get negative 0 minus 2 is negative 2 squared plus 8. Well, negative 2 squared is 4, but then the negative out front makes it negative 4. And then if we take negative 4 plus 8, well, that gives us positive 4, which is the same number we got when we looked off the graph, right? At 0, we were at a height of 4. So either way, whether you plug in 0 or whether you look off the graph on this one, you'll see that the height that the ball was released from was 4 meters.